Hello, student. And here is the lecture for today. I think we're gonna go to start two short video, and basically just the kind of the more practice for two topics, Kirchhoff laws and series and parallel circuit. Okay. So let's start with the first one. We're dealing with the question that before we start for the multiple choice or for the lecture warm up, multiple choice questions, when you're given the three resistors, they are connected in series, as we mentioned, connected to the series one, follow the others, and ask you to what the value for the equivalent resistors for this connection, so for the circuit. So for the series connections, we have the R equivalent, just adding those resistors together. So it's R plus 50 ohms plus R. So you end up with the 2R plus 50. So there is no resistance by negative or less than 1. So basically, all the value that we got, it is supposed to be larger than 50. So from here, we're gonna go to the second choice. That's where it came from. Okay, so let's start with the first example here. We're given a circuit here and a bunch of the resistors, the R3 resistor, 15, 20, 25, and fed by 5 volts. And we ask to find the equivalent resistor for the circuit. The equivalent resistors means I can replace those 3 resistors. I just put one single resistance. How we can find this equivalent, this resistors? That's the equivalent part that we're gonna do. So we have this particular equivalent circuit. Here is the 5 volt, and here is my R equivalent. So equivalent mean both two circuits that are the same. What the value for the R equivalent? So we have when we have the resistors connected in parallel, so the equivalent resistors, just adding 1 over the first resistors, 15 ohm, plus second resistors, 1 over 20 ohms, plus 1 over 25 ohms. So you can use your calculator to find this one. If my calculation is right, so I calculated here, it is 0.1567. Regarding for the unit, this is still 1 over ohm, so still 1 over ohm. So R equivalent, which we basically just inverse this value, 1.1567, 1 over ohms, and I end up with the value, it will be 6.4 ohms. So I can connect the circuit here with the 6.4 ohms. That's the equivalent resistors in the circuit or resistors that are connected in parallel. One note I wanted to emphasize in the circuit here, the value that I got, 6.4, it's supposed to be less than any resistors here. The minimum resistors or the lowest resistors here, 15 ohms. So I should be confirm my equivalent resistors should be less than 15 ohms. You have to make double check, guys. Let's move for the second one from here is the practical life. We have the Christmas tree and many light. And that Christmas tree mini lights contain 2 sets of the 25 bulb. So which means here is the 25. And the second one will be 25. And they ask you to what the equivalent resistance for that connections. So basically what that means, I have bulb with the bulb with the bulb. They are connected in series. And the equivalent or the resistors for each bulb 10 ohms. So basically what do we have? We have 25 series connections. So the equivalent resistor for this branch will be 10 times 10, 25 times, or 10 times 25, 25 ohms, and 25 ohms for the lowest resistor. So basically what do we have? If I represent all my up lights with one single equivalent light, and represent the lower bulb line with the one single equivalent line, and feed this one in my 120 light cycle. What the value for this one? This one is 25 ohms, and similar for this one, 250 ohms for both two resistors. Where it's come to 50 here is 10 times 25 is 1250 ohms. I have one single resistors and 25 light bulbs. Now what I do, I have those equivalent resistors in parallel, so I can connect them, or I can find the equivalent resistors by the formula that we used before. In the equivalent, it will be equal 1 over 250 ohms plus 1 over 250 ohms. And if you count this one and you flip it around, you end up with the R equivalent will be 125. Again, if you remember, we're talking about if I have two resistors, they are connected in parallel, the equivalent resistor should be a half of it, half of the resistors. So I have 250 here, 250 here. The equivalent resistor should be half of this resistors, 125 ohms. What happens if any bulb here is that, take it out here, and still my volt is still applied for those 25 light. Okay. And if the circuit is not going to the short circuit, mean that the only change I gonna got here is gonna be 24 light. This one included by 0 by short circuit. So in that case, this might be more brightening than the upper one. Let's move for the next example here. Quite complicated. We mix the resistors together, and we have those 4 resistors. We need to find the equivalent resistors between A and B. So the first one, we go from the inner to go to the out. So the first one I have to do it, I have to find the equivalent resistors for this one. Okay. The equivalent resistor for this one, let's call it here is the 1 over R equivalent 1. It will be 1 over 30 ohm plus 1 over 45 ohm. If you want to do it an easy way, multiplication divided by addition, multiplication divided by additions, mean this one is the 30 times 45 divided by, add those together, 75. Here is the ohm. If you calculate this number, you end up with the 18 ohms, again, less than 30. So now my circuit will be, looks like this one. And this is second part. Now this one is still 40. And here is the my A. And here is the my terminal B. And here is still 42 ohms. And here's the R equivalent one, which in this case 18 ohm. Now what I gonna do? I have to go to find the equivalent resistor for this part. Okay, equivalent resistor for this part. So I will go this way here. So in this one here, I have series. So 42 plus 18 will be 60. So I end up with this resistors, with 42 parallel resistors. Here is the equivalent to, or that we call it R equivalent to, by adding those two resistors together, which equal 60. 60 ohm. Where is the 60? You confuse yourself. 60 just adding 42 plus 80. What we have the second one, here is the 40. 40 ohm. And here we have A and here we have B. Now, to find the equivalent resistor in that case between A and B, here is the A and here is the B, and here is the equivalent resistor in that case. 1 over R equivalent will be 1 over 60 ohms plus 1 over 40 amps. And from here, you can get R equivalent to the multiplications, which 0, 0, 24 divided by additions 100. So from here, you end up with the 24 ohms. So here is 24 ohms equivalent resistor in that case. Okay, so this is the first short video, and see you next video for more example regarding for the Kirchhoff and series and parallel circuit. Thank you so much for listening, guys.